Good morning, students. So today we are going to discuss chapter 1 exercise 1.3 problems, and this exercise is most important for the board examination point of view. You can see in the last 10 years every year one question is coming from this exercise. So this exercise, if there is no doubt, I can make you sure this exercise contains one questions of 3 marks each. So you must be practicing this exercise very carefully, and the whole chapter is carrying, as I already told you, 6 marks. So the problems coming from the real number is of 6 marks, out of which for particularly this exercise one question of 3 marks will be there. So let's discuss question number first. Prove that under root 5 is an irrational number. In class 9th we had studied about rational or irrational number, and in fact we know that under root 5 is itself irrational number because this is neither terminating and nor repeating decimal form. Okay, but today we are going to prove this, that under root 5 is an irrational number. So the method which is used here, that is contradiction method. Okay, so let us prove this by taking contradiction method. Let's assume that under root 5 is not an irrational number. Under root 5 is not an irrational number. Then this would be what? If a number is not irrational, then it means the number must be rational, because the real number is of composition of two numbers, that is rational or irrational. So here we are assuming the number is not irrational, so it means ultimately this number would be rational number. Then this can be expressed as P by Q form. Why? Because the number is rational. So under root 5 equals to P by Q, where P and Q are co-prime number or integer. Co-prime means the number P and Q are in its simplest form, that is the HCF. Co-prime means HCF of P and Q is 1. Highest common factor of both the numbers are 1. Okay, so on simplifying this, we get by cross multiplication P equals to under root 5 into Q. Now squaring both sides, we get, so after squaring both sides, the square of P is P square, okay, and the square of under root 5 is 5 only, and the square of Q is Q square, right? So clearly what we see, that this 5 divides P square. If I find the value of Q square, then Q square will be what? P square upon 5. It means we can say that P square is divisible by 5, or we can say 5 divides P square, right? So we can write any statement. So we are writing P square is divisible by 5. It means P is also divisible by 5. That is a theorem in NCERT. So you just write only by theorem that if a number 5 divides p square, then the same number 5 also divides p. That is, this is square without square. The 5 will also divide p. For example, if I write the number in place of p square, 5 square is divided by 5. This 5 square is divided by 5. Then the number itself 5 is also divisible by 5. Right? So using this fact, and this is also proved in NCERT. Okay, so we can write only by theorem. This number p is also divisible by 5. It means if a number p is divisible by another number 5, it means 5 is a factor of p. Because a number divides the other number, then it becomes its factor. So 5 is a factor of p. Then we take, if 5 is a factor of p, it means we can take an arbitrary value of p as 5c. We can take the value of p is what? Multiple of 5, because 5 is factor of p. 5 is factor of p. So we can take some other also numbers like 25, 625. That is a multiple of 5. So we cannot take as many as numbers together. So we are writing what? A c. I mean where this c is some integer. Okay, so p equals to 5c. We can assume this equation first. Now that value p equals to 5c, we will put here in this equation first. Equation first is p square equals to 5q square. Now from, and assume this result as this one as second, or this result as third. So from equation first, what was first equation? P square equals to 5q square. Okay, you can see p square equals to 5q square using equation first. So now putting value of p, which is assumed here in equation third, in equation first. So we get, so substitute the value of p. What is p? 5c here. 5c. So we are writing the value of p, that is 5c here. So p square means 5c square equals to 5q square as it is. Now the square of this 25c square equals to 5q square, right? Now on simplifying this 5 cancels 25 by 5, so we get q square equals to, what we are getting? 5c square. 5c square. It means what? This 5 divides q square, or we can say q square is divisible by 5, because the value of q square is what? It's coming 5c square, multiple of 5. So 5 divides q square. This implies 5 also divides q, as we already discussed here. If a number divides 5 divides 5 square, so 5 also divides 5. So using this fact, and this fact is already proved in theorem, so the derivation of theorem 1.2 is not in your syllabus, so you have to write only by theorem. So 5 also divides q. It means 5 is a factor of q. Assume equation 4, because 5 divides q, it means 5 becomes factor of q. Now look at the equation second and 4. What is the equation second? 5 is a factor of p, and equation 4, what we have got? 5 is a factor of q. So if we combine equations second and 4, so what we can conclude? Equation second and 4. From equation second and 4, we conclude that five is a common factor of p and q. So we have concluded that 5 is a common factor of p and q. And earlier what we had assumed, do you remember? See, the beginning of the question, we had assumed see p and q, root 5 p by q, where p and q are co-prime integer. Co-prime integers means HCF of p and q is 1. HCF means common factor. Common factor of p and q is what? 1, which is what assumed earlier. And now what we have proved? We have proved 5 is also common factor of p and q. So this is what? This is contrary part. It means we can say which is a contradiction to our assumption. Because we had assumed that 5 is what? Having common factor 1, that is co-prime factors p and q was assumed, and now we are getting what? 5 is also its common factor, and we had assumed 1 is only common factor. It means we are contradicting what? Our statement. So which is a contradiction to our assumption that under root 5 is not what we had assumed. Under root 5 is not irrational number. This was what we had assumed. It means this is what? Contradiction. So necessarily under root 5 is what? An irrational number, and we had assumed it is rational number. By taking rational number, we had concluded 5 is a common factor, which is wrong, because if 5 is a common factor, then p and q will not be having what? Co-prime numbers, right? So necessarily under root 5 is what? An irrational number. This is the proof result. So on the basis of this question number first, okay, this is your homework, that you will prove in the similar way, same statement, only I am changing the numbers. Prove that under root 2, under root 3, under root 5 I have solved. Okay, so replace 5 and take 2, 3, 7, and even in this year this question was asked in 3 marks. Prove that under root 3 is irrational number. This question is asked in this 2020 board examination. Okay, you can see the question paper also. This question was asked in 3 marks. So under root 2, 3, 7, under root 10, under root 11. Okay, so if you do practice all these, then one questions or any other number if it comes, then you will be able to prove that these numbers are also irrational number. So you will prove by taking this contradiction method. Okay, so there are 2 types in this exercise. This is a type 1, when individual irrational number coming. Okay, and now the second question I am going to consider of NCERT, that is another type. Question number 2. Prove that 3 plus 2 under root 5 is an irrational number. Okay, so what we see here, there is a combination of rational and irrational. This is rational number and 2 root 5 is irrational number. Okay, so the sum of rational irrational we studied in class 9th is also an irrational number. So this is what we have to prove, and this is what second type 2. Type 1 under root 5 irrational, that is only a single irrational number was given, and this is what the composition of rational and irrational. So it comes in type 2. So the same method we will be using, that is contradiction method. So let us assume, let's take or assume 3 plus 2 under root 5 is not an irrational number. It means if this is not irrational, then what it would be? Then that is means 3 plus 2 root 5 is what? Rational number. Because we are assuming this is not irrational, so it must be rational number. And if this is rational number, so by the definition of rational number states that this can be expressed as the form of P by Q. Okay, where P and Q are co-primes, or you can say they are integer. Okay, P and Q are integer. Now this implies, simplify this, so P by Q minus 3. Now what I have to check, this 3 has been transposed to the right hand side. So because this is a plus symbol, so it will be becoming minus symbol. So P by Q minus 3. Now take LCM. Q or 1, LCM is 2, Q cancel. So 1, that is P minus, we divide this 2 by 1, so Q will come and becomes 3Q and LHS 2 root 5. Okay, so take LCM. These are the areas where almost students gets confused in taking LCM or transferring this 3 from left to right. Okay, so be very careful. Now under root 5 equals to P minus 3Q upon, what happens now? Rewind. This 2 will be what? Going here. Right? Many students writes this 2 what? With minus sign. That is wrong, because here 2 is coming what? Product of under root 5. So 2 will be coming where? In denominator. That is product with Q only. So we have got under root 5 equals to P minus 3Q upon 2Q. Equation first. Now P and Q are integers, as P and Q are taken as or assumed as integer. So what is the left hand side? I mean numerator of this side, right hand side, P minus 3Q. Okay, so P minus 3Q becomes what? Also an integer, because P and Q are integer, so P minus 3Q is also an integer. This implies P minus 3Q, this is the integer, and in divide, what was coming? 2Q is there. Okay, so let's check. 2Q is also the integer, so this whole number, that is integer or integer, becomes what? irrational number, because this is again in the coming of fraction, that is p by q form, right? So what was in left hand side? Remember, left hand side was what? Check once again. Under root 5. Under root 5 is what? Irrational number, because we proved in question number first. And this is what we have proved. What we have proved becomes rational number. So this is what? Right hand side. It means right hand side becomes rational number, and in left hand side what's given there? Under root 5, that is irrational number. So can a rational or irrational number be equal or not? Of course not. A rational number cannot be equal to irrational number, because both are different number, distinct number. So this is what? A contradiction. Contradiction means this is not possible, okay? Which is not possible. That is, it is a contradiction to a assumption, right? It is a contradiction to a assumption. So therefore 3 plus 2 root 5 is an irrational number. So this is the question number second. Alright. So question number first we have discussed if there are individual numbers, and this is the question number 2, and there is question number 3, composition of this first and second part. Okay, so I hope you practice, you understood this concept, and try to solve the question number 3. Thank you. Bye.